Hello everyone. Today I am here to discuss simple stress and strain. Now in the simple stress strain chapter, I'll discuss in today's lecture about the stress, different types of stress, strain, and different types of strains. Also, I'll discuss the relation between stress and strain. So let us start. Now look at these images. Different situations are there with different expression. But in all situations, one same feelings that we can notice, and that is we called as stress. Means whenever some external agent or external force comes into play within any human beings, then up to a certain limit, we can resist these external agents or external forces. But after this limit, we can resist. So we will express with the help of this expression, and that is called normally stress. In many cases, under pressure, at the offices, at these colleges, at your home, if we feel pressure very much, then we normally becomes stressed. So we will call as, yes, I am stressed. So similar case happened in this case also, the fourth one. That is, the body has been pressed, and because of pressing, because the application of the compressive force, the body get deforms. Now we'll study in this chapter about the deformation of a solid body and how the stresses are developed in a solid body. So again, the next is the definition of stress. Now, what is stress basically? Or what is the stress in a solid body? When an external force acts on a body, the body tends to undergo deformation. But due to the cohesion between molecules present in the body, a resistive force, also called a restoring force, will generate inside the body, which acts against the deformation. And that is in nature also. If any force acts on a body, then normally the body will first try to resist that force. That is, the body will always try to remain in equilibrium. Within a certain limit called the proportional limit, the resistance offered by the material is proportional to the deformation due to the external force. Also, it has been found that within the proportional limit, the resisting force is equal to the externally applied force. And here the definition of stress comes. Stress is defined as the resisting force, or we can say the applied force per unit cross-sectional area of the body. And beyond the limit, the resisting force becomes less than the applied force. And then the deformation will continue until the failure or fracture occurs. See in the animation, in this animation, compressive force is applied to a body and the body get deformed, and after a certain limit, the body fails. So mathematically, we can say that stress is equal to applied force divided by cross-sectional area. What is cross-sectional? See this animation, cross-sectional area. I have shown what is the cross-sectional area. If you cut a body, then the section cut section is the cross-sectional area. And the unit of stress is Newton per meter square. Now, how is stress to be calculated? See this figure. There is an object, three-dimensional, 10 millimeter length, 5 millimeter width, and 15 millimeter of height. And there are two forces. One is 100 Newton force acting along the x-axis but in compressive nature, and another is tensile nature force 50 Newton acting along y-axis. Now I want to find the stress produced or stress developed due to the force 100 Newton and due to the force 50 Newton. So you see this 100 Newton force acting over this area. And what is that area? It is area 5 multiplied by 15 millimeter square area. So if I want to find the stress developed due to this 100 Newton force, then stress will be 100 divided by 5 into 15 millimeter square. So I have calculated it here. It is 1.33 Newton per millimeter square. And this is compressive in nature. Normally in sign convention, we will take compressive nature stress as negative stress. And again see in the y-axis, there is this force 50 Newton, and this 50 Newton is acting in this area. This area is 10 millimeter multiplied by 5 millimeter. So it is 50 millimeter square area is there. So if I want to find the stress on this plane, then that is force is 50 divided by 50. So it is 1 Newton per millimeter square, and this is a tensile stress. So in this way, we will calculate the stress acting on a plane. Now, we know the unit of pressure is also Newton per meter square, and unit of stress is also Newton per meter square. Then what are the differences between the stress and the pressure? This question normally asked in any interview. So we can see stress develops in solid bodies, while pressure develops in liquid and gases. This is the first difference. In solid body, we will find out stress, but for liquid and gases, pressure will be developed, no stress. Stress act normal or parallel to the surface. Means stress may be normal stress, maybe shear stress. But pressure acts normal to a surface with compressive nature. Pressure is always in compressive nature. Pressure is always compressive in nature. There will be no pressure which is tensile in nature. Stress is a type of internal force that acts over a cross-sectional area within the material. But pressure is a type of external force that is exerted over a surface area of a material. Stress may be developed due to pressure. Means because of pressure, stress may be developed inside the body. But pressure is not developed due to the stress. Then stress is a material property. Stress is a material property, but pressure is a thermodynamic property, or we can say it is a physical property. Stress depends on area, pressure is independent of area. Stress depends on area because stress is force per unit area, cross-sectional area. So it depends on area. So these are the difference between stress and pressure. Now, what are the different types of stresses? Normally, there are two types of stresses. One is normal stress, another is tangential stress, or we can say shear stress. So what is normal stress? If force acts perpendicular to the plane of the body, then stress developed is known as normal stress. Depending on the types of applied force, means force may be tensile or may be compressive. If the force is tensile, the nature of the stress is tensile stress. If the force is compressive, then the nature of the normal stress is compressive stress. Similarly, if the force acts along the surface of the body, then stress developed is called shear stress. Look at these two figures. In the first figure, there is a compressive force acting on the plane. So it will be a normal stress. It will produce a normal stress. But in the second figure, a force acting along the plane. Force acting along the plane, so it will produce a shear stress. So these are the types of stresses. Now what is strain? See, strain First of all, strain is a dimensionless parameter. When a body is subjected to an external force, there will be an elongation or contraction. That is change in dimension of the body depending on the types of force, whether it is tensile or compressive. Now look at this animation. There is a spring and load weight is acting at the end of the spring. Spring is fixed at this end. So this is the original length, and after load, the extension is given. So we can say strain is defined as a ratio of change in dimension to the original dimension. Change in dimension to the original dimension. So it is a dimensionless number. Okay, so hence strain, we can say, if I say from this figure, we can say the strain E is equal to extension divided by original length. Now, types of strain. Again, there are two types of strains. One is called linear or longitudinal strain, another is called lateral strain. Then what is linear strain? Strain occurs along the direction of applied load is known as linear or longitudinal strain. The direction in which the forces will be applied, stresses or strain on that direction will be linear or longitudinal. That is a clear-cut definition. The direction along which the force will be applied, strain in that direction will be linear or longitudinal. Suppose you are applying a force or a load along x direction. So linear or longitudinal strain will be in x direction. Then what is lateral strain? Lateral strain occurs along the direction perpendicular to the applied load. Perpendicular to the applied load. That is, look at this figure. Here is a force load applied along the x-axis, horizontal axis, and it is a tensile force. Pulling, this material has been pulled by tensile force. So longitudinal strain or linear strain will be along x-axis. And the perpendicular of x-axis is y-axis. So lateral strain will be along y-axis. Okay. So the lateral strain will be compressive in nature and linear strain will be tensile in nature. Suppose again conversely or vice versa, if I apply compressive force along the x-axis, then linear strain will be along x-axis, but lateral strain will be in y-axis. But in that case, linear strain will be compressive, lateral strain will be tensile, lateral strain will be tensile. So that depends on the types of force. So if the linear strain is tensile, then lateral strain will be compressive and vice versa. Hence, every linear strain is accompanied by a lateral strain. Here there is an important term called poisson ratio. So poisson ratio, the ratio of lateral strain to linear strain is always constant for a material, and this constant is known as poisson ratio. And it is denoted by mu. So mu is equal to lateral strain by linear strain. Mu is equal to lateral strain by linear strain. So these are the two types of strain. Now shear strain, which is very important. What is shear strain? Now look at this second figure, this one, the force is applied along the surface, top surface. So the top surface is being distorted by a certain angle, So here is the original dimension, is the deformation. So this A angle is called the shear strain. So when a force is applied along the surface of a body, body deforms with an angle, and that angle is normally called as shear strain. The shear strain has been denoted by an angle. So shear strain is the ratio of deformation to the original dimension. This is deformation, this is original dimension. Perpendicular line is the original length and deformation is the horizontal one. So deformation by original length is equal to tan of A. And since A is very small angle, so tan A is approximately equal to A. So in engineering, shear strain is the tangent of the angle and it is equal to the length of deformation at its maximum divided by the perpendicular length in the plane of force, which is this one. Then another strain is there normally we will use, that is volumetric strain. So volumetric strain is the ratio of change in volume to the original volume. The definition of strain is change in dimension to original dimension. Since it is a volumetric strain, so it is the ratio of change in volume to the original volume. Look at this animation. Original volume is V. Original volume is V, and due to the application of this compressive force, the final volume, the change in volume is delta V. So the volumetric strain is delta V delta V divided by V. Okay. So with this, okay. Again is Hooke's law. Hooke's law is the law which defines or states the relation between stress and strain. Basically, Hooke's law is an empirical law. Empirical law means it's derived from observation. When a force is applied to a body, then up to a certain limit, the deforming force is directly proportional to the change in length. The deforming force, that is the applied force, is directly proportional to the change in length. Deforming force means load applied because of deformation, or the body is deformed due to the load. That load is called the deforming load or deforming force. So we can say that F dF is proportional to change in length delta L. So F dF is equal to K constant delta L, where K is a constant of proportionality. Sometimes if it is found that F rest is equal to minus K delta L means K. If F is equal to minus K in delta L, then this F is a restoring force. This F is if F is equal to plus K into delta L, then F is a deforming force. And if F is equal to minus K into L, then F is a restoring force. Because restoring force is opposite to the deforming force. Restoring force means force which produces or induced inside the body to counteract the deforming force. So it is opposite to the deforming force. The modified version of Hooke's law is stress is directly proportional to strain up to proportional limit. So stress is equal to some constant K into E. This K is called the elastic constant. Hence elastic constant K is equal to stress divided by strain. So if I want to define the elastic constant, so elastic constant is equal to is the ratio of stress upon strain. So with this I have completed today's lecture, and the next class I will explain the different types of elastic constant and relation between elastic constants. If you have any doubt or any queries, please you can mail me at my mail ID. It is nurulhasan2@gmail.com. NURULHASSAN nurulhasan numeric 2@gmail.com. If you find my video good and workable for you, then please share it, subscribe it. Thank you.